Good morning, students. Now we will see how we can do the program for multiplexer using structural model. Okay, the structural model, so all of you know that multiplexer many to one. Okay, so by using the selection line we can select the we can get the output based on your selection line. Okay, so today we'll see this structural model for 4 to 1 mux. Okay, you have to select the file, new project. Here you are giving project name where we are going to store your programming. Okay, then next, then again you have to select the families, what are the families, what are the devices we are going to use, what is the package, all these things, and similarly synthesis tools, and similarly what are the simulator we are going to use. You have to select all these things and click next. You have to verify that we have selected the proper family, all these things. Okay, you can see these devices, device family, devices, package, speed. If everything is correct, you can go for finish, otherwise go back and again you have to assign the proper devices. Okay, here it is, everything is correct, you can click finish. Now you have to create a new source. This is the previous is project name. Here we are giving what type of program we are doing for, that is a new source. Create a new source, double click, there you will get Verilog model. You have to give the proper file name, right, 4 mux. Okay, program, click next. Here we not give this is structural model, you should not give it input. You click next, finish it, and now here you have to write your program, you have to type your program here, right. So now here you can see the model max 4 mux is given. You have to give, here I am going to give the 4 inputs, right, I0, I1, I2, I3, and we are using for this for 4 input you require 2 selection line, S0, S1. So your output is Y. Okay, ma'am. So now you have to tell what is the input, I0, I1, I2, I3, S0, S1, and output is Y. Now we are connecting the wires, right. So wire, because we are using AND gate as well as OR gate. So the AND gates are wired with connected with OR gate. So that we have to use this wire. Well, the wire is, we have to give here, we are using 4 AND gates. So the 4 wire connected with AND outputs are connected with input of the OR gate. So I am giving wires are P, Q, R, S. Okay. Now we will see this AND gate. So first AND gate consists your input. Okay, you have to assign the input, and what is this, S0, that is, yes, suppose S0, 0 means it will select first input, 0, 1 means it will select second input, 1, 0 means it will select third input. If it is S0, 1, S1 is also 1, it will select fourth input. So this, that way you have to give your program. So and A1, P, the P means wire, P wire, and I0, that is input, and S bar, S1 bar. The second one, A2, the wire is Q, and then I am assigning wire, okay, Q wire for and A2. Then my input is I1, S0, and S1 bar, and A3 I am assigning wire R, and the input is I2. This is S0 bar and S1, and the fourth one is my fourth AND gate is I am assigning S wire, and my input is I3, and my SS, that is both the selection lines are both the selection lines are 1 1. Okay, these are all connected with OR gate. I am assigning R O. No, O means output. Okay, the outputs are, you will get Y output. It is nothing but it is Y, or output is Y, that is output Y. That the where you are getting the R inputs are, the inputs of this R's are P wire, Q wire, R wire, S wire. That's why I given like this. Okay, then N model. Okay, now you have to save it. You have to synthesize, select your file name, Now you have completed this program. Now we have to verify that is there any bug in this program. Okay, so select the synthesis and check the syntax error. So green is visible, so there is no error in this program. Now we have to synthesize it. Okay, here we can see all the gray signal, so there is no problem in the program. Now we have to simulate it. Behavioral, select the behavioral, create the new sources, and we have to verify this marks with the waveform. Have to give the file name. Next, click next. Now you can select the clock information, combinational, finish. Now we have to assign the input. Okay, here I can assign the I0 either 0 1 0 1 and I1 similar way I1 I2 I3. I3 I4. So now I also give S0 S1 also, S0 S1. You can select a 0 1 0 1. Right, now we will see the save this information. Create it, select the file and simulate it. You have to simulate this program. Then simulate the behavioral model. Okay, click the simulation. Now we can add the marker. So add the marker. Now we will see the output, right? So first initially the S0, S0, S1 is 0 0. Okay, S0 S1, let us consider S0 S1 is 0 0. Change it 0 0 0 0. Now S0 is listen, S0 S1 is also both 0. Here my I0 is 0, so I am getting Y is equal to 0. Now we will say change. You can see here both input S1 S0, both inputs are, both selection lines are 1. Then it should select whatever the data in the I3, that you will get output. So I3 is 1, so Y is also output is 1. Okay, the next one you can see here S1 is 1 and S0 is 0. Okay, I said my selection line is 0 1. 0 1 means I2. So 0 1 means it is I1. So whatever the I1 in data, that Y is 1. Okay. So similar way you can check your output. So whatever the data given in the inputs, either 0 1 2 3, based on the selection line. If it is 0 0, it will I0. Is 0 1 1, 1 0 2, and 1 1 3. So this way you can check your multiplexer. This is the way to you do your program. You can also try with your laptop. Thank you.